Good morning, everyone. I am Dr. U. Shakti, working as Assistant Professor in Computation Intelligence Department, School of Computing, SRM Institute of Science and Technology, Kottayam. Today, we'll say the topic linear search. Search is one type of problem. Here, searching is a process of finding a particular value or key value in a set of values. We are searching for a particular element in a array. That's called searching. There are two types of searching, linear search and binary search. Linear search means search the array value one by one. We are searching for key K. We are searching from the starting place in the array to the last element in the array. From first to last, one by one. That is called linear search. And what is binary search? Binary search is based on divide conquer method that we will see in the next presentation. Next, linear search is a sequential search algorithm, and it search the key value linearly from one end to another end of the list. And the searching process starts at the first place, that is A of 0. See the example, A is array name. It has 6 values. The index variable range from 0 to n minus 1, that is 0 to 5. So starting place, the points first element in the list, stop is the last element in the list. There are two cases, key is 34. So first we are comparing array value with the key value. If the value is equal to the array value, search key K value is equal to the array value, the element is present. If it is not equal, go and compare with the next element. See the example 34 and 5. We are comparing 34 and 5 not equal. Again, we are comparing to the with the next element 17. 13 and 17 not equal. Again, 34 and 6 compared, that is not equal. Again, 34 is compared with the 8, it's not equal. And compare with the next value, 34 is equal to 34. Now the two values are equal. That means the search key K is present in the array. If the search key is present in the array, the algorithm will be terminated. The algorithm displays the element is present and immediately the algorithm will be terminated. See the second case, key equal to 7. So it starts from first place. Compare all the elements one by one till the last. K7 is not present in the array. So in that case, it displays the element is not present. So there are two cases, the value is present or not present. The search key process starts at the first place and travels all the elements one after another till the key is found. Otherwise, the search process is continued till the last element. Algorithm outcomes, there are two outcomes of linear search algorithm. Search key is present or the search key is not present. There are two results. And linear search operations, here the basic operation is comparison. So we are comparing the key value K with the array value A of 5. So I value varies from 0 to n minus 1. What is n? N is the size of the array. That is number of elements in the array. So see the example, the input is array A, array size n and search key K. Here A is array name, I is the index variable that points the values in the array, and n equal to 5. So there are 5 elements, index starts from 0 to n minus 1, key equal to 54. We are searching for the key value 54 in the array. First, it starts at the first place because the linear search. So compare 54 and 23, not equal. Go and fetch the next element. Again 54. So 54 is equal to 54. So the element is present in A of 1 location. So in that case, the algorithm returns the element is present. For example, we are searching for some 5, key value 5. So compare the 5 with the 23 not equal, 5 and 54 not equal, 5 and 31 not equal, 5 and 67 not equal, 5 and 54 is not equal. The entire array will be traversed. The element is not present. In that case, algorithm displays the search key K is not present in the array. See the code. Check if A of I is equal to key, then output found. Else go and get the next value and compare with the search key K. This is a basic operation of linear search. Algorithm name is linear search. Input is array A with n values. So index range from 0 to n minus 1. It contains n elements and search key k. So input array A contains n elements and search key k. What's the output? If the search key k is present, algorithm returns the index of the search key. That means index where it is present in the array. That is called index. Location of the search key value in the array is called index. And if the value is not present, algorithm returns -1. And so start the algorithm. Input array and search key k. Start the for loop for I equal to 0 to n minus 1. For every value of I, algorithm compares the value of array with the search key value. For initially I equal to 0, so we are comparing a of 0 with search key k. If it is equal, then output the index I and go to step 7. If the array values and search key values not equal, go to the step 3. Step 3 is again I is incremented. It will be compared, search key k is compared with the next element in the array. So it will go till n minus 1. Okay, if the array values equal search key value, output the index and stop the algorithm. Else, the element is not present, step 6 will be executed. If it is present, step 6 will not be executed. If the search key k is not present in the array, step 6 will be executed, that is output -1. The value is not present, algorithm returns -1. This is a flow of linear search algorithm and the working of linear search algorithm. The example, see the example, basic operation is comparison. We are searching for search key k12. So we are comparing search key k12 with the array value from 0 to 4. That is from start to end, 1 by 1. All the elements are traversed. And if I equal to 0, a of 0 is 12. So search key k is present in first location. That is a of 0 equal to search key k. So both the values are equal. So element is present in, search key element is present in first place of the array. In this case, algorithm performs only one comparison. So here the basic operation is equal operation. So we are, in best case, algorithm performs only one comparison. If the k is present, algorithm will be terminated. So best case of n is equal to 1. What is 1? In the best case, algorithm performs only one comparison. Best case on input size n is equal to 1. So when we write order of growth, best of n is equal to order of 1, which is a constant value. So when the best case occurs, if the search key k is present in first place of the array, algorithm performs only one comparison, that is the best case. In this case, it performs only one comparison. So time complexity is, for best case, is order of 1. It's a constant value. And come to the worst case. Worst case means the algorithm performs maximum number of basic operations comparison. That is called worst case. See the example, there are two scenarios. So you take k equal to 10, n equal to 4. There is 4 values. Index range from 0 to n minus 1. So it starts from a of 0. So k equal to 10. That is compared with array value, first value 12. 10 and 12 not equal. Go and fetch, compare the next element 5. 10 and 5 not equal. Again 10 and 24 not equal. And last place, a of 3, 10. So search key k is 10 is equal. A of 3 is equal to search key k. That means the element is present in last location. In this case, search key is compared with all the elements in the array. So we have n elements. There are n number of comparisons. So search key found in the last place, algorithm performs maximum n comparisons. And take the next case, k equal to 8. So 12 will be compared with the first value. 12 and 8 not equal. Again 8 and 5 not equal. 8 and 24 not equal. 8 and 10 not equal. In the second case, 8 is not present in the array. If the element is not present, algorithm performs maximum number of comparisons, that is n. In that case, the search key is compared with all the elements in the array. So it performs n comparisons. For each value, one comparisons. So totally there are n elements in the array. So maximum n comparisons. So if the element is not present, the array is over. The search key k is not present in the array. So in the worst case, there are two cases. The key is present in last place or the key is not present. Algorithm performs maximum of n comparisons. So worst case complexity, worst case on input says n is equal to n because it performs maximum n comparisons. All array elements are compared to the search key. So it performs maximum n comparisons. So worst case on input says n is equal to order of big O notations. This order of n, which is linear growth. That is called worst case. So see the algorithm, how it is implemented in C language. That is linear search C program. So the second part, we have the main code. So int main, so driver code int main. So int a of 100, input is a and key, and n is size of the array, and I is index variable. First, we're getting the size of the array n, and input array, the function will be called. So we have to write, apply the concept of modularity. What is modularity means? Instead of writing complex program, we can split the program into number of subprograms or functions. So that will improve the performance of the code. So function call to the input array. So we have the function call input array. We are passing array A and N. So on the left side, the second module, void input array. So we are passing array A and N. Within the code, it will get n values using for loop. For I equal to 0, I less than I plus plus, scanf, read A of I. So after executing the function, the call will be returned to the main function. Next statement of the function call. Again, it will enter the search key k. So it will ask for search key. User has to enter the key value. Again, function call for linear search. So int result is equal to linear search of a of n comma k. So linear search function will be called. This is a function call. The function returns some value. Here in the linear search function, we are using return keyword. This function returns the value of integer type. See the definition, int linear search. So this function returns some value of integer. That value should be stored in some variable, that is int result. So result is the variable that accept the return value of function linear search. Again, the function, the control will be transferred to the linear search. Here we are having the for loop I equal to 0 to n minus 1. That is all values are traversed from 0 to n minus 1. Here we are comparing using if statement. If array value a of I is double equal to key, that means the key is present in array. If it is equal, return I. Immediately the function control will transfer to the main function, returns I. I is the location of key value. If the key is present, it returns a location where it is present. Now, for example, the worst case, the input key is not present in the array. For loop will be terminated. It will check for 0 to n minus 1. For all the values, if condition always false because the value is not present. If condition always false, after the for loop, it will go to the return minus 1. The next statement, return minus 1. So minus 1 means the key value is not present in the array. So whatever it may be, the index or the minus 1, function returns the value that will be stored in the variable result. Again, we are comparing the result value. If it is equal to minus 1, result is equal to minus 1, the element is search key k is not present in the array. Else, the value is present at the location, the result. So that is the output of the linear search algorithm. There are two cases. If the value is present in the array or not present in the array. If it is present, the value is present in the first place or last place or in between the first and last. So that is a case for linear search algorithm. And see the example, output 1, enter the size of the array 3, enter 3 elements 10, 18, 34. We are searching for key value 4. Here see the 3 values, the 4 is not present. So algorithm, C program prints element is not present in array. See the second output. There is second sample output. Enter the size of the array 4. Here the 4 values are entered. We are searching for 4. The value is present in index 2. That is 0, 1, 2. In the index 2. So this is the output of possible output of linear search. Analysis of linear search. What is time complexity? Time complexity means how much time algorithm takes to produce the result. That is called time complexity. Here in linear search, the basic operation is comparison. That is, we are comparing A if A of I equal to key value. So the basic operation comparison decides the time complexity. So execution time of the algorithm depends on number of comparisons the algorithm performs. So time complexity of linear search algorithm is based on how many times the comparison operation is performed. That is the time complexity. So there are 3 cases: best case, worst case, and average case. The best case already we discussed. The search key K is present in the worst place. Algorithm performs only one comparison. So best case complexity of linear search is 1. So the best case algorithm performs only one comparison. Again, worst case and average case. Worst case means the key is present in the last place or the key is not present. That is the worst case. So in that case, algorithm performs maximum n comparisons. So worst of n equal to n. So worst of n equal to order of n. The order of growth is linear. So this average case complexity also of linear search is also order of n, which is linear. So this is a time complexity. Best case is order of growth is 1, that is constant. For worst case and the average case, time complexity of linear search is order of n, that is maximum n comparisons. And what about the space complexity? Here in this algorithm, it uses only array A and search key K. It does not require additional array or additional variable. All the operations are performed in the array itself. So in this case, it doesn't need any extra memory. So the time complexity of linear search is order of 1. That is, it uses only one array, input array A. So the the space complexity of linear search is order of 1, which is constant. See the table. So for linear search algorithm, worst case is order of n, average case is order of n, best case is order of 1, and the space complexity is also order of 1. Thank you.